With this video, I'm going to go over the entire lesson for section 10.3, which is probability. It's the first real lesson that we're getting into with probability. And I'm going to go through the entire thing here, so that way if you struggled with it at all, you can just review this, or if you were absent, that will work as well. The objectives of today's lesson are as follows. We're going to calculate some very basic probability questions. I like this lesson because it helps me win at different board games that I'm playing. Just really kind of easier stuff that I'm doing anytime I'm playing like Risk or Yahtzee or that kind of things. Then probability helps me to perform better at those games, helps me beat my relatives. So that's always a good thing. Now, here we go. We've got a coin that we're going to flip, and we're going to flip it twice. So we need to think of the possible outcomes of flipping a coin. If we flipped it twice, let's see, we can have heads or tails. There are two options. If we flipped it once, it would just be heads or tails. But if we're flipping it twice, we can have it be a heads and a heads. Both of them can be heads, or maybe they can both be tails. So we want to list all the different possibilities that there are. So we've got a heads heads. It can be a heads and a tails and a heads, or a tails tails. And these two kind of look basically similar. They both have a heads and a tails, although they are in different orders. We could have flipped a heads first, then a tails, or we could have flipped it would have been different, a tails first, then a heads. And this is becoming important. This is what we're going to refer to as our sample space. And sample space is all the different possible outcomes that are even out there available. So there are 4 different outcomes we can have if we're going to flip a coin twice. Now we want to say, what's the probability of getting 2 heads? Now, the probability of getting 2 heads, we look up here and we have only one of these has 2 heads in it. So the probability of getting 2 heads is 1/4. The way that we calculate the probability is we take the desired outcomes. This is how many times can the desired outcome occur. This is desired would be 2 heads, divided by the total possible outcomes that are available, and that's 4. Okay, the amount in E, our event, in this case it's 1, divided by the total sample space. But if you think of it in terms of desired, what we're wanting, in this case 2 heads, divided by the total available, that will get you the same thing too. Okay, so let's go a little bit further. We know what our sample space is. This is just like the one that we just did. You're flipping a coin twice. There are 4 possibilities. Now, we want to determine what the probability of getting heads at least one time. So we go through here and we can look at our sample space. This one definitely has a heads at least once. So does this one, and so does this one. So we end up finding out that there's 3 different times that can occur. So our probability of getting at least 1 heads in those 2 different coin flips is actually 3/4. Now we can take it a step further and go, what is the probability of getting heads only one time? So our same sample space here. If we want to get heads only once, that one wouldn't work. These 2 middle ones would. So that would be just 1/2 there. All right, now I want you to try these 2. We're going to do the same thing. Now what I'd like you to do is just pause the video, work these 2 problems out, and then you can push play again whenever you're ready to check your answers. So go ahead and hit pause now. Check your answers here to make sure that you got the right answers. And again, showing a 3, there's only 1 3 in an entire 6-sided die. So 1 divided by 6 would be your answer here. Even, there are 3 different even ones. You've got 2, 4, and 6. So your probability would be 1/2 on that one. Let's try another one. Here we go. Now just pause the video right now and you can come back after you've got your answers. Okay, hopefully you were able to determine that there are 4 kings in the standard deck and 52 cards in a standard deck. Now, if you're not familiar with the standard deck, you're going to need to be. We do that quite a bit in probability. They give a lot of variation to what we can do with probability, so you want to familiarize yourself with the standard deck. If you're really not sure what's in a standard deck, you can also go on. I do list that on the Canvas website. That gives all the different cards and how many of them there are. If you can't locate that, just Google it. It'll have everything there for you. All right. So hopefully you found that out. Face cards, there are 12 face cards in a standard deck. Ace is not a face card. That's an important one to remember. All right, let's try this one now. Go ahead and calculate this one, and then go ahead and push pause, calculate this one, then come back. Okay, double check your answers here. That should have worked just fine here. Again, we're still dealing with rolling a die. Let's go back to our card problem for the next one. Just trying to get some practice here is the big thing. Go ahead and pause the video now. Okay, now the probability that it's not a face card, this one was interesting because the probability that it was a face card was 12, so you could have subtracted that from 52. Or you could have counted up all the possible cards that were not face cards. If you counted correctly, you would have gotten 40 out of 52. And when we're dealing with the standard 52 card deck, let's clarify one thing real quick. The jokers do not exist in a standard 52 card deck. You don't normally play with jokers in a game of... In most games you don't have jokers, so you would not include those in a standard deck. Now we're dealing with 2 dice. So we're going to roll these 2 dice and we're asked to list the sample space. Now there are 36 combinations of that, and you can write down 36. That's real great, but it doesn't give us enough information to be able to answer the next question. So if you can, write down every possible outcome that you have. You can have a 1 and a 2, you can have a 1 and a 3, you can have a 1 and a 1, a 1 and a 4. If you list all those out, here's what it should look like. So here are all of your different combinations. You can have a 6 and a 1. Now notice here that a 2 and a 1 and a 1 and 2 are 2 different ones because there are 2 dice here. So you could roll a 2 with the first die and then a 1 with the second die, or you could roll a 1 with the first die and a 2 with the second die. So that is possible. That's why there are 36 possible. Okay, so when we're looking at this here, here's the way our probability question will be posed. It says find the probability of getting a sum of 10. So this is why it's important to list all of these out. It makes it a lot easier. Which one of these add up to 10? If we're adding the 2 units together, let's see, 6 and 3 is 9, so that doesn't work. 4 and 6 here is 1. Also right here, 5 and 5 is 1, and 4 and 6 is 1. So it looks like I have 3. 3 of those out of a total possible of 36. So 3 out of 36 is 1/12. You'll see that I colored them in red just to make it a little bit easier. Okay, now on this one here, I want you to go ahead and do this one. Pause the video right now and you can come back to it after you got your answer. Okay, and here we go. Here's the answer. We've got 6 of them. Hopefully you found that out. It got a little bit different because the sum is sum of 4 or less. We're going to include 4 in there in our totals here. 4s, 3s, and 2s would be our totals there. So there are 6 possible out of 36, so 1/6 would be the way that we do it. This one we're asked, what is the probability of rolling a 4 on a die, then flipping a coin that lands on heads? So we've got 2 different events here. One is rolling a die, and the other one is flipping a coin. So if we've got a die here, this is a standard die, 6 different sides to it. What's the probability that we're going to roll a 4? Well, only one side has a 4 on it, so it would be 1/6. Our desired over our total number possible, so 1/6 would be our probability of rolling a 4. Then if we have a coin has 2 different sides, so the probability of flipping a coin and having it land on heads is going to be 1/2. Now these 2 events need to occur either exactly at the same time or one right after the other, consecutive events. So what we're going to do here in order to calculate the probability of both of these occurring is to multiply these 2 together. So 1/6 times 1/2 would give us 1/12. Alright, now let's try this. It's your turn. Let's have you try a couple. Go ahead and pause the video now and then come back after you've completed your answer. Okay, and you should have gotten 1/10 on this one. The big thing here that you want to really pay attention to is that Hayden put the sock back. Because he put it back, there are 10 to draw from the second time. Had he not put it back, had he kept the sock, this one here would be 5 9ths, and then we'd multiply 1/5 times 5 9ths. But in this case, he put it back, so there were 10 to draw from the second time. All right, now let's try this one here. Go ahead and pause it now, and then come back after you have your answer. Check your answers here. These are the same ones here. This one is one in which he kept it. In other words, we started with 21 socks. He kept it, so that means there are only 20 to choose from the second go around. So that would have been the only one that would really trip you up on that one. So anyway, that concludes this portion of the lesson. I do have additional videos for each specific problem pertaining to the homework, but this is the entire lesson altogether.